Inverters are the brains behind your solar power system. They take the DC direct current electricity from your batteries or solar panels and convert it to AC, which is alternating current, which is what your TV, fridge, fan, and other appliances use. But not all inverters are created equal. The type of waveform they produce, whether it's a pure sine wave or modified sine wave, makes a big difference in how your devices perform. This right here is a modified sine wave inverter. It is called in Nigeria pure water inverter. I don't know why. It converts power in a step square like wave, not smooth like utility electricity. That means it's cheaper and more accessible. But is it good enough? Now let's put the modified sine wave inverter that I have right here to the test. I'll be powering a few appliances and let's see what actually happens. Would I blow up something? I don't know. Let's find out. This is a pure sine wave inverter right here. It's not hybrid. Hybrid is when you have a combination of what the inverter does with your charge controller. So it has an inbuilt charge controller, but this one specifically does not have an inbuilt charge controller. It's a 24 volt, 2 kVA, pure sine wave, 1600 watt inverter, which is actually pretty awesome. I love that it has a screen actually. I've not actually tested it to see how it works, but in the next video I'll actually be testing this and I'll see, you know, what is the screen for actually. Can I actually do any settings on this? Because most of the inverters that you will find, especially with hybrid inverters, you can do like some sort of settings on them for it to actually work very well, but I don't know what this will actually do. So in the next video, expect this. I'll be showing you how this works. This right here is the battery that I'll be using. It's a 12.8 volt 200 ampere lithium ion phosphate battery. This is from GSD Solar, and yeah, it's just pretty basic. So I have my terminals here. I'll just be connecting the inverter to this. So one of the things that you will notice when you newly open the box is this cable right here. So you get like this very short cables. It's not this short in other ones that you buy, but for this particular one from Songfa, you get this cable. So I'm just going to be using this cable to connect the lithium ion phosphate battery that I have here. Right down a little bit. I have my negative and my positive, so I'll just connect this to the negative right here. And the inverter is on. As you can see, there's a green light there, so we'll just see. Let's try and test it with some things and we'll see if it actually works. First, let's test with this fan, see if it works. So here's the actual plug right here. So it's currently on the max. This is 3. So that means it works actually. And the funniest thing is I can't actually hear any sound from this. So definitely something is different. Naturally, you would have started hearing that humming sound. Increasing it to actually see if we can blow up the inverter, or maybe not. This is a bigger aux fan. Yeah, 135 watts. Well, the inverter is 2000 watts, so you should be able to handle it, I think. So let me just face this away so that it doesn't affect the camera. This is the highest, and somehow I'm still not hearing that sound, so it's actually pretty awesome. To the next test. This is another test. Let's see if this is actually going to work for this electric kettle. I have Sophia here. Sophia, what do you want to make with the electric kettle? Which one do you prefer, tea or coffee? Let's see if this is actually going to work. It's on, so all I need to do is push this button right here. And let's hope we don't blow up something. So you want to just move back a little bit. And it went off, so it's showing like some sort of fault here on the inverter. Let's try to put it on again. The same thing, so you get that fault. 2560, so you should be able to actually do it at least for some minutes, but it's not actually lasting at all. So go back to using the inverter to make coffee for Sophia. So finally, I have this ceramic plate cooker right here, and the beauty of this cooker is that you can increase the wattage to what you want exactly. So I can start from like 100, then keep going till I get to like 800, 900, 1000. So this will allow me to know what would actually shut down the inverter right here. So I'm just going to plug this in, and I'm going to call in one of the engineers so that we can have a little bit of safety around here. Engineer is here, so let's turn on the inverter, and it's on. I think at this point it's not eating up or anything, so we have to turn it on first. Soup, for example, the default setting is 1800, so we reduced it to 100, so it's currently eating up at 100, and you can feel the heat a little bit. And let's increase to 300. That's 400. There's no 300. Okay, so let's wait a little bit for it to allow it to heat up. 400 is still a good number, so that means that this inverter can do 400 watts. It says 2000 watts on the inverter itself, but we are not sure. So let's keep finding out. Let's increase it again to whatever number it gives us. 600. So that means it can do 600. So it's at this point it's pretty hot, and that's not bad. Okay, so let's keep going. Can it do 800? Let's see. 800. Wow. And it shut down. So that means the max for this inverter right here at 2000 watts is actually 800 in reality. Well, for a modified sine wave inverter, it actually does so much, because you won't hear any beeping sound, any sound actually. So, and it was actually able to actually power this, which is actually nice. So at 800 watts, the inverter shut down. Put it out of the battery, and one of the things that I noticed that the inverter is very hot. I don't think it was actually designed to pull out that much power. And there's this smell. Did we burn it? I don't think so. It actually still works after. Let's open it and let's see what's inside. The major thing is really the board. This long board that you have here, so there's really not so much weight. This inverter says 2000 watts, and for this inverter that I have here, and I'm going to be reviewing very soon, it says 1600 watts. So how come very heavy? How come this is bigger than this? I will explain. For this inverter, which is a modified sine wave inverter, it is built with just MOSFETs, capacitors, and small driver circuits, like you will see in there. It chops up the DC into a squarish waveform. No transformer used inside. That's why it's light, cheap, and not ideal for sensitive or heavy appliances. But for this, on the other hand, it's a transformer-based pure sine wave inverter. It includes a large copper transformer, more advanced PWM control, filtering capacitor, inductors, and heat sinks. The transformer steps up voltage and smoothens the waveform to match grid quality power. So grid quality like your NEPA. And that's why it's heavier, more expensive, but better for all appliances. If you enjoyed this video, please like, share, and subscribe. We'll catch you in the next video. Talking more about equipment, solar, batteries, and inverters like these, all right? Or bigger inverters. And if you have any inverter that you actually would want us to review specially, please write it in the comments below. We would love to hear from you. Till next time, cheers.